Seventh graders, we are starting chapter 8. Now, chapter 8, what does it cover? Chapter 8 covers graphing quadratic functions. So today we're going to start off with the beginnings of what a quadratic function looks like. So today, what are you going to learn? You're going to learn how to identify characteristics of quadratic functions and how to graph and use quadratic functions that are in this form, f of x equals ax squared. So identifying characteristics of a quadratic function. How do you identify them? Well, a quadratic function is a nonlinear function. Make note of that. It's not a line. And that can be written in the form ax squared plus bx plus c equals y. So y, once again, it could also be f of x. Now, a cannot be 0. The U-shaped graph of a quadratic function is called a parabola, not a parabola. It's a parabola. In this lesson, you are going to learn how to graph quadratic functions, where b and c are equal. So later on, we're going to add in b and c. But right now, b and c are equal. So we're just going to deal with y equals ax squared. So let's look what our characteristics are. The parent quadratic function is f of x equals x squared. Previously, we've talked about parent functions in exponential equations, exponential growth and decay. Y equals x is the parent function of a linear equation. So now we're going to talk about the parent function. Now this is it. X squared, y equals x squared, f of x equals x squared. The graphs of all other quadratic functions are transformations based off this parent quadratic function. So we have a lot of information here. This right here is our parabola. The lowest point on a parabola that opens up or the highest point that opens down is called the vertex. So in this case, the vertex is 0, 0. The vertex of the graph, the parent function, is 0, 0. The vertical line that divides the parabola into two symmetric parts. So in this case, it's the y-axis. The left side and the right side are both symmetric. This is called the axis of symmetry. The axis of symmetry passes through the vertex. For this graph, y equals x squared, the axis of symmetry is the y-axis, which is the line that is called x equals 0. This is going left to right. Graphs go left to right. Even though there's an arrow here, we go left to right. So as this is decreasing, it decreases as it approaches the vertex. Once it hits the vertex, it increases. So let's look at the graph that we have. Here's a graph. Woo, graph. Consider this graph. Using the graph, identify characteristics such as the vertex, axis of symmetry, and the behavior of the graph. So when I say to analyze the graph or identify characteristics, this is what I'm looking at. You could say that the function is decreasing as it approaches the vertex. The vertex is the lowest point since it opens upward. The vertex is negative 1, negative 2. After the vertex, the function is increasing. It opens upward, and you'll notice the axis of symmetry is this line right here, this dotted line, which represents the equation x equals negative 1. What else could you tell me? Well, you could talk about the domain and range. The domain, in this case, is all real numbers. The reason why it's all real numbers is because x value can be anything you want. You can plug in anything you want to this equation. The x value keeps going up. However, the range is different. There's nothing below what value of y. Here's the lowest value of y. And what is the y value here? It's negative 2. So that means your range is all real numbers greater than or equal to negative 2. All real numbers greater than or equal to negative 2. Some other things you can determine. And this is really important that you understand where I'm getting this from. What's the x value at the vertex? The x value is right here, -1. When x is less than -1, what is y doing? Y is going downhill. Remember, we always look at graphs from left to right. So as x approaches -1, when x is less than -1 though, y is decreasing. But you have to make sure that you tell me what we're doing, because y could actually increase if you're going this way. So here's what we got to look at. I'm going to tell you the direction that we're going. So I'm going to say when x is less than -1, y decreases as x increases. What that means is, as you're going this way, look at what your x value is doing. Your x value is going to the right, which means it's getting bigger. So your x value, so here your x value is like -4. Here it's -3. Here it's -2. And then here it would be -1. As your x value gets bigger, your y value is getting smaller. However, when x is greater than -1, what happens? As x is going this way, when x increases, what's happening to y? Y is also going up. So y, we could write y increases as x increases. Y increases as x increases. Now you could also take what you have here. You could have also said when x is less than -1, so when x, here's your x value, once again we're talking about the red region, you could say as x decreases, y increases. So if you're going this way, as x decreases, which means x value is going to the left, your y value actually goes up. So you could have this reversed, and it would also be correct. So in this example, I want you to identify the characteristics of the quadratic function and its graph. So pause the video and tell me some things you know about this graph. Hopefully you could tell me that the vertex is going to be -3, 7. The axis of symmetry is right here. And so the axis of symmetry is x equals -3. The domain, x is all real numbers. But the range is going to be less than, all real numbers that are less than or equal to 7. Since the highest point here, the maximum value for y is 7, everything is less than that. So what else can you tell me? Well, you could say when x is less than -3, and we pick that because that's our vertex. So when x is less than -3, we could say as x increases, y increases, which it does. As your x value goes to the right, your y value also increases. But when x is greater than -3, as x increases, y is decreasing. You could also say that backwards. You could say as x is greater than -3, you could say as x decreases, y increases. So either one of those would be correct. But this is all of the characteristics, all of the information that you can gather from a graph. Here's our next core concept. We're going to talk about this right here. The value of a. Now notice in each of these, a is going to be the number that you multiply to whatever you plug in for x squared. If the value of a is greater than 0, so let's look at this. A is 1. So the blue is your parent function. So I just want you to look at this. Blue is the parent function. If A is between 0 and 1, it's in red, which means it gets wider. It's a vertical shrink. I would also call this a horizontal stretch. It's stretching it. So the red represents if it's 0 to 1. But if it's greater than 1, look at this. If it's greater than 1, it makes it steeper. So actually it's a vertical stretch. So a vertical shrink pulls it left and right. It's getting wider. A vertical stretch means it's getting narrower. It's getting a higher value. So this green is when the number is bigger than 1. The red is when it's less than 1 but bigger than 0. Now what happens if it's less than 0? Less than 0 means it's negative. So as you can see, if it's exactly -1, it reverses. If it's between -1 and 0, once again, it's a vertical shrink. It gets wider. I would also let you call that a horizontal stretch. If it's less than -1, which means the value gets bigger here, in the sense of a negative. The negative value is actually getting smaller, but you could get -2, -3. It's actually going to stretch it vertically. So this is a vertical stretch. Step 2, we're going to graph it. So we have the function g of x equals 2x squared. Step 1, I am going to make an xy table. And in this case, we use g of x. And I'm going to plug in some values. I would plug in some negative values and some positive values. So I'm just going to plug in from -2 to 2. When you plug this in, don't forget your order of operations. If I plug in -2, -2 squared is 4. 4 times 2 is 8. And I'm just going to fill these out. The math here should not be difficult. So if I plug in -1, I get 2. If I plug in 0, I get 0. If I plug in 1, I get 2. And if I plug in 2, I get 8. Now we're going to graph this. If you graph each of these points, -2, 8, -1, 2, 0, 0, 1, 2, and 2, 8, you form a parabola. And there it is. So now I want to compare it to the graph of f of x equals x squared. So there are a few things you could say. You could say both graphs open up. If you wanted to draw the parent function on here as well, you could do that. So let's say that you did do that. And if you did do that, you would get something that looks like this, which is completely fine. But you'll notice some things that are the same. Both graphs open up. They both have the same vertex of 0, 0. And they have the same axis of symmetry. The axis of symmetry here would be x equals 0. However, this graph, the blue graph, is narrower because it's been stretched vertically. Notice right here, this coefficient is 2x squared. Because that number is greater than 1, this is going to be vertically stretched. And what is it vertically stretched by? A factor of 2. So let's try example 3. Graph h of x equals -1/3 x squared. I'm going to make my t-table and x and y. Notice I don't use y. I use whatever it says here. In this case, it's h of x because we're not using y. We're using h of x. And let me erase that and redraw that. So I'm going to plug in any value I want. Now you can plug in any value, but since I'm taking a third, I'm going to choose x values that are multiples of 3. So I'm going to pick, let's say -6, -3, 0, 3, and 6. So if I plug in -6, that'd be -1/3 of 36. That would give me -12. If I plug in -3, that's -1/3 of 9. That would be -3, 0, -3, and -12. So now I'm going to graph this. And I ran out of room with -12, so I could have counted by 3s if I wanted to. This would be my parabola. you'll notice that it's incredibly wide. So what do we know about this? Well, we know that both graphs are the same in the way of the vertex. So they both have the same vertex, and they both have the same axis of symmetry. However, this graph, the function h, opens down and is much wider. Therefore, it's a horizontal stretch, or you could say a vertical shrink, by a factor of that right there, -1/3. And you could also say it's a reflection in the x-axis of graph f. Our last example shows us a real-life problem. The diagram at the left shows the cross-section of a satellite dish, where x and y are measured in meters. Find the width and the depth. Well, this is pretty easy because you can look, domain. Now, if I asked you for the domain, your domain is only and can only be -2, which is the lowest point, and +2, which is the highest point, right here. So, what values are from -2 to 2? Well, remember, we're counting by halves here. Make sure you understand that this dish is counting by halves. So your domain are only those values. So the width is going to be 4 meters. And the depth, which is, if you look here, it goes by halves, would just be 1 meter. So if I asked you for your range would be what? The lowest y value is at the origin. The highest y value is right there at 1. So your range goes from 0 to 1, which means you have a depth of 1 meter.